Hi, we're here with Jesse Lesperance from Sikorsky, and behind us is a Sikorsky Black Hawk helicopter that can actually be autonomously controlled. Now Jesse, when you talk about autonomous vehicles and cars, quite often what you're talking about is a thing that looks like a mechanical man sitting in the driver's seat and it's attached to the steering wheel and the pedals and the shift knob. But when you autonomously run a Sikorsky Black Hawk helicopter, that's not at all what you do, is it?
No, Sikorsky's approach to autonomy is a little different than what you would typically understand as remote controlled. Sikorsky's focus is on taking a platform like the Black Hawk that you know and trust and providing more effective capability to increase its safety and increase its capability overall. Sikorsky's focus is primarily on increasing autonomy more from the user perspective, providing a level of interaction and autonomous capability that allows him to interact with the vehicle more as a mission system operator than an actual operator or pilot.
Now, Jesse, when a pilot sits in this thing, he's basically doing a fly-by-wire operation where he's really just talking to the control computer, correct?
Yeah, it's a full authority flight control system, more commonly known in industry as like a fly-by-wire system, where depending on the interface, whether you have a conventional helicopter type of interaction with the collective and cyclic controls, that interaction, that interface is provided electronically to the flight control system in the vehicle management system, more so in the optionally piloted Black Hawk, because you're really providing inputs and cues to the computer what you want the aircraft to do, and the aircraft's interpreting those inputs based off of what its capability is and its mission set.
Okay. So a remotely piloted Black Hawk is basically talking to a pilot on the ground who's using something like a tablet or a remote control to just talk to the flight control computer, right?
Correct, yeah. Actually, last year we did a demonstration on this aircraft sister down in West Palm Beach, Florida, and using basically a tablet-sized device with a data link, we were able to control the aircraft through a full resupply mission using that tablet device. That's one instance where you're looking at it from the perspective of giving that capability to somebody externally from the vehicle, what we like to refer to as our 2-1-0 capability. If you have two pilots in the aircraft, not only can you give those two pilots increased safety and additional capability, if one of those guys needs to focus on something else and really just hand off over that control as a mission operator to one person, you can do that. And also if you have nobody in the aircraft, or you want those two guys to focus on something mission focused and not really on the aircraft operation and flight controls, you can go into zero pilot mode or zero crew mode that allows you to enable that.
Jesse, when somebody's flying a little hobby RC plane and he kind of nosedives it into the ground, it's usually just a Styrofoam plane, it's no big deal, but if you nosedive one of these things into the ground, it'd be a bad day. How do you train the operators of this?
Yeah, so we're focused on more safety and reliability at the platform level. So, you're correct when you're looking at something that costs a couple $100s, your cost of replacement per flight hour is relatively low. When you're talking to something that's Black Hawk size and Black Hawk cost, you can't afford to have a loss rate of 1 in 100 flight hours, or even 1 in 1,500 or 10,000 flight hours. You have to have a very robust system in order to ensure that you're not damaging anything in the aircraft or potentially damaging somebody on the ground or injuring somebody. We focus on this from the perspective of system safety. So the way we architect the autonomy system, known as matrix technology, is focused on that robust system, using a known and trusted platform, adding its smarts to the aircraft and mechanical systems to be able to control it in an optionally piloted mode. That allows, going to your point of training, when you have that increased autonomy and capability on the aircraft side, it can actually offload the training requirements to the operator, because he's not so much focused now on pilotage training, which typically is the standard for helicopters and Army aviation, but you're now looking at more mission training, where you're focusing less on actually how to keep the aircraft in the air and more focused on what the aircraft's doing when it's in the air.
Great. Well, that's interesting technology, Jesse. Thanks for taking us through it.
Yep. Thank you.